Hello everyone. Welcome to the first session of the third week of the course of Introduction to Modern Applications Development. Last week, we saw the command line version of the Fair Share application. We also saw the graphical version of the same application. The command line version was a simple code that actually implemented the basic algorithm that we saw in the very first week of this course. As written, the command line version illustrated a procedural style of programming in a Java language. Despite Java being an object-oriented language, we used it to program in a procedural style. However, the object-oriented facilities support that Java has was used during the graphical version of this code. In the command line version, we distinguished between interactive and non-interactive style of interacting with the user. Our command line approach was very non-interactive. In other words, all the relevant information that was required for operation had to be given right on the command line before our program started running. Our program had three different modes or user commands as we called them. The registration mode, which began an interaction of the registered roommates. This was followed by one or more expenses mode, where the application recorded various events for which the amount of money and the roommate who paid were recorded. The third mode was a reporting mode. This mode was used by one roommate to ask the system what is the money that he or she must either receive or pay. We have introduced some errors, or it's not really errors, we have introduced some shortcomings in the program that we had presented during the command line. We hope you have found what they are, if any, and you have improved upon them. The command line version, as presented, also illustrated some aspects about how to design a user interaction. One of the restrictions that it gave was the command could be used by one and only one roommate at a time. The graphical version improved a little bit on the command line rigidity. It provided interactivity and more than interactivity, it allowed the user to not worry about the exact syntax, but focus on the information that is to be manipulated. In this case, the only information that really is required by the roommates is the amount of money and events for which expenses were made and by whom. The command line forced us to remember it in an exact syntax, that the word, for example, the word expense had to come after the command but before the amount. It was not possible to switch the two. So, for example, you could not say that the fair share command should be followed by the amount and then followed by the name. You could do that only if you change the architecture or the programming inside the fair share program. the graphical version allowed us to be free from such kind of a issue. Nevertheless, both the graphical as well as the command line worked on a single computer. They could be used by one and only one roommate at a time. At this point, it is possible that some of you may object. Well, today, most operating systems that we use on our computers are multi-user. So all we need to do is to have multiple users on that machine. Sure enough, that is possible. But at any given point of time, your machine would be used by one and only one single roommate. If another roommate uses it, then he or she logs in into his or her account on that same machine, but at any given point of time, one and only one user is using it. Second, we have not designed our command line program such that it works with multiple users simultaneously. For example, it uses a single database, a file as a single database. That file is the same whether it is being run by user 1 or user 2. This gives rise to a lot of problems. For example, if both users try to change the file at the same time, how do we handle that? We have not programmed our system for such a thing. So even if our program can run on a multi-user system, it's not really strong enough to deal with the complexities of a multi-user system. It is by design a single user program. At some point, we would like to generalize this to make it multi-user, so that multiple users can run the same program. Okay. These were some of the things that we saw in the past week, where we developed a command line as well as a graphical version of our fair share application. We now take the next step in this week. Although graphical version of our application was a wee bit better than the command line version, both of them worked on a single computer and a single user. To put it in a different language, if our fair share program is considered as offering a service to the roommates, then our computer becomes the access point for that service. And one way to describe the situation is this service has a single access point. So a consumer of the service, which is any of the roommates, will have all of those consumers will have just one single access point. Our next step, therefore, is to see how we can change it from a single access point to multiple ones. This is where we will introduce networking. Computer networks allow us to actually increase the number of access points for that service. In our case, we will again proceed step by step. First, we will only focus on presenting the output, the results, over the net. In other words, we will be separating the user interface from the processing. So the results of the processing are presented out to the user, and it is this part that is going to be separated. On our command line, the user interface is presented, the output is presented on the terminal, but that terminal is on the same place as the machine is. Similarly, for our graphical system, what we would like to do is to take the output user interface from the local machine to a remote machine across the network. If such a thing were done, because now the output is networked, and at some point later even the input is networked, this will allow us to have multiple access points, each connected via the network to the single processing system. So multiple access points will be possible, and all our roommates will be able to access the fair share application from different points, not necessarily the same computer. We will look at this aspect in this session. The key idea of separating the UI from the processing is in appreciating a few basic points. Output devices render data. Input devices ship in data. Neither of them really produce new data. They don't generate anything. If we could just standardize the rendering, we are focusing on standardizing the rendering because we right now are interested in just generating the output. Why do we standardize? The graphical application as well as the completely command line version of our application, both of them presented some very interesting concepts to us. The command line version argued that there are a variety of output devices, and instead of dealing with all of them, let us create an abstraction called as the standard output device. We wrote our programs to just print on the standard output device, and we left it to the operating system to decide what that device would be. In contrast, a graphical application could not do that. It in fact got stuck. Depending on the particular graphics system that you have used to program, the way you presented out, I mean the code that you wrote to present out, would differ significantly from one way to another way. This is very similar to the scenario of having a variety of output devices. And just like on the command line application we created a standard output device, we need to do something similar for graphics, and that is what standardizing the rendering means. How do we standardize? Well, we use HTML and CSS. In fact, HTML and CSS are the universal user interface. That is what we would like to really draw your attention to. Before we go to HTML and CSS combinations, let's take a quick look at what do we mean by graphics. At its very core, as we might have learned it in a computer graphics course, graphics is either raster or vector graphics, and it deals with two main aspects: information and interface. Information is of various kinds. It could be textual, it could be numerical, it could be audio, it could be visual, it could be video. By visual I mean an image or a graph or a thing like that. Our video is more motion oriented. On the interface side, we have a variety of input-output mechanisms ranging from touch, tactile, to pointing devices, typically a mouse, audio, video, and so on and so forth. Just like our standard just like on a command line application, our output hardware could be varied. We standardized by creating a standard output device. This allowed our programs to be written very simply. They simply print on the standard output device and rest is taken care of by the OS. In the same way, if we standardize the graphics system over here, then we could take the output display from local machine to the local machine or from local machine across the network to a remote machine. This possibility opens up. This is what gives us our standard web tools, the HTML, the CSS, and what we call as the document object model DOM. There are times when we feel that it's better to view the web as a system of three entities, the HTML, the CSS, and the DOM. The HTML is about what to display, the content. HTML, as it stands for hypertext markup language. What it means is that the content to be displayed is marked for the kind of presentation it should be. It's a logical marking. So as an author, I might say that I want to, in my content, I want to start emphasizing my content from point A to point B. I just say that I want to emphasize it. I mark the emphasis from point A to point B. Now it is left up to the rendering system to actually draw. Not only does it draw, it first decides how to render. So it might say that an emphasis is to be done in, say, maybe with an underline. Or it might be possible to even imagine that an emphasis will be done by just changing the color. This separation from content and presentation is one of the key factors that makes the web so interesting. Apart from the HTML, our next entity in the web is the DOM, the document object model. The document object model specifies the logical structure of the components of HTML as well as CSS. In fact, a document. So it says that a document is made up of a head, a body. A body would be made up of a header followed by a paragraph, maybe one or more paragraphs. It could have a subheader, which could again have a paragraph. It is this tree-like structure starting from the document, the body, the first header, the paragraph of the header, and so on and so forth. This tree structure is what the document object model really captures. This framework that the DOM offers is specified, how to use it is specified by HTML, and how to display it, how to present it is specified by cascading style sheets. At their simplest, cascading style sheets simply specify how a certain markup element of HTML is to be rendered onto the output system. Note that this allows us to specify or adapt to different output systems by simply changing the style sheet. So for example, if our device were a video device, then we could mark up by using visual cues. So for example, we could mark up by changing the color used for emphasis. On the other hand, if our output is a simple sound speaker, audio channel, then an emphasis could be in terms of changing the volume. by simply making it much more strong to say that. So the actual presentation details for a given device are handled by the CSS. So the CSS really deals with how to display using the content that HTML supplies. We will gradually build up more as we go along. But we suggest that you really look at the main source of information about these standards HTML, DOM and CSS on the World Wide Web. You will find this information at www.w3.org. Let us now go ahead and look at the actual application. What we are going to show is from our purely command line application, we are first going to create a bare HTML version of our application. By bare HTML, I mean our application will only output completely only in terms of HTML. Having done that, we will then go to the next step where we will add styling information via style sheets. We are going to use style sheets in a very simple manner to illustrate how the styling change occurs just by using style sheets. So again, we will be going by first changing from a pure command line application to a bare HTML application, and then we will add as a next step style sheets. The final comment here is I would want you to note that our fair share command line application is a procedural style of using Java, and we will be changing that same piece of code to create an HTML or bare HTML, whatever case it may be. We are going to change the same command line application. You might want to actually change the object-oriented version of the application such that it generates HTML and HTML with style sheets. This could be a good point to take a pause. Here is our command prompt. We already have written the Java programs that we need, and here is the fair share application. This is exactly the same program that we had seen last time when we did the command line, when we actually did in detail the command line version of this program. As you can see, it started from main and then went on to do setup and process command lines, arguments, and so on and so forth. Let's compile this program and create a class file. The Java compiler javac.exe that we have used has been installed at the point that we have shown on our screen. Please use your path name for your Java compiler. This changes because it depends on where you have installed your Java JDK system. So wherever you have installed your Java JDK system, within that folder, go into the bin folder and then you will see your Java compiler. So here we go. Voila, it has compiled successfully. Let us now execute this. Again, the exact path will vary for each one of you because it depends on where you would have installed your Java JVM. The way we use the fair share application is by using any one of the three user commands, but quite naturally we will start by registering our friends F3 and F4. Let's just say 4 of them are there. Voila, it has registered 4 friends. Let's have some sample expenses. Let's say F3 spent some 200 rupees. Okay, it complained. I made a mistake, spelling mistake. There you go. So an event where F3 spent 200 rupees for the entire set of roommates is recorded by our application. Let's record a few more. Say F1 spends 100, maybe F4 spends 250, whatever maybe. So we have at this point had 3 events and paid for by the roommates that we just saw, F3, F1 and F4. F2 does not seem to have paid. So maybe let us start by asking the report for F2. Oh, F2 is required to pay 137 rupees and 50 paise to others. Let's see what about F1. F1 is required to pay 37 rupees 50 paise to others. But what about F3? F3 is to receive 62 rupees 50 paise from others. And then finally F4. F4 is to receive 112 rupees 50 paise from others. I don't know whether in this particular case the invariant is satisfied or not. In other words, although our program recorded all the various events in the lives of that group of roommates, they registered, they spent for 3-4 events, money was spent. I would like to be sure that whatever is the amounts calculated, they are correct. We leave it to you to verify if they are correct or not. In the meanwhile, let's proceed with the bare HTML program. So, the fair share bare HTML Java is the program that we are now going to compile and run. There you are. It has compiled it successfully. Let's of course run it now. Let us start afresh by registering the friends again. There seems to be some problem. Let me check out. Oh, okay. I need to compile again because I forgot to name my class correctly. There you go. Unlike the command line version of this program, our command gave out a lot of output, which is actually HTML. And as the name stands, it's a markup language. So for example, over here, H2 marks header level 2 and /H2 /H2 marks the end of that header. So whatever is the information in between is marked by HTML to be header level 2. Now when this HTML reaches the browser will then decide how to render header level 2. In other words, it could render it by, say for example, making it a bold font or underlining it or maybe changing the color, whatever way the user of the browser desires. Our program generated this output and the standard output. Let us capture this into an HTML file. And let's open this file in a browser. There you go. The output of our program is now an HTML form, and it is the browser that can show it. Note that this was just registration, therefore it said that it is registering roommates. There are 4 of them. It says that it has found 4 roommates, and that registration is done. It was not asked to do any expenses, nor was it asked to do any report. As far as the database information is concerned, it says yes, there is a file of that kind, but it is a fresh start and so there is no data in it. Let's go back to our command line and add some data, which means the data about expenses. So let us say that friend F1 spent some 250 rupees. It again gave HTML output. And what we should have done is redirected that output to an HTML file. Let us, for clarity's sake, keep the two HTML files separate. So the file that was generated by our program when it did registrations, let's keep that separate from the file that it generates whenever we do expenses. We will also keep the third file whenever we do reports. Let us take up a new tab and open up the file when we did expenses in this new tab. Compare it the things over here. It says roommate registrations. Now it says registered roommates are whatever they are, and now there is an expenses information. Adding an event with expenses whatever by whichever roommate. There was no report requested, and if we scroll down we see now that there is a database. It has found 2 events. There are 4 roommates, and here are the events. Note that because we ran the program twice, it shows 2 events by F1. Let's look at, say, F3 spending maybe, oh god, 450 rupees. And let us reload this. Okay, you have 3 events. Number of entries in the database is 3. Over here F3 has spent 450 rupees. This event was added, and the other display is the same as before. At this point, let us ask for reports, and as I said before, collect the results in a separate file. We have been leaving F2, so let's ask a report for F2. Let's look for file C and then open it. As before, it informs us about the registered roommates. It says that no expenses were recorded, and F2 and the amount F2 owes is 237 rupees 50 paise. If we go down in the database has no more events, no extra events than before, so the number of events is 3, and the number of entries in the database is still 3. Which, if I come to that, it's 200. Let me just make a quick calculation. 250 and 250 is 500, and 450 is 950, and that is to be divided amongst 4 people, which probably is correct now. Our F2, since he or she has not contributed so far, is now supposed to pay the entire contribution. So this shows us how the bare HTML file program works. Let us now go ahead and do the same with the final version. This is a point where you can stop, review the material, and then come back. Let us now go ahead with the CSS version. In this, we are going to add CSS code to our HTML part. As before, let us simply examine it. Okay, we have our HTML version, HTML and CSS version over here. Let's, as before, compile it using our Java compiler, which is typically in some path of your installation. There you are. Let us, as before, run it. We will be running a okay. We need to register roommates. It again gave output, and as usual we should really capture the output in some file. We will preserve the earlier files for our own reference, and so we will take it in, instead of ABC we will say XYZ, x.html, y.html and z.html. So x.html will contain the registration version. Let us go ahead with some expenses as before. We are just adding some sample expenses. And again, as before, let's take a report for F3. We had ignored F3, so let's have a report for F3. What I have done during this time is I've first collected all the HTML output of the entire program, and then now we will open it in a browser and see how it looks. First of all, I should open x.html because that represents the registration, but this time with CSS. Let's see how it looks. Okay, but that was because, again, as before, I forgot to copy the CSS file here. Now if I reload, there you go. This is the same bare HTML file, but this time it has been touched by CSS and the presentation has been changed. The presentation, there is, I hope you can see, a very drastic change in the presentation. The registration part is highlighted in blue. All the details are separated out: expenses, reports, database information, and the fact that it's a fresh start, that is a no database. So let's look at the expenses record. Which was in y.html. There you go. But notice the difference. The roommate part is no longer in blue, and the registration expenses record is in blue, but the report part is not in blue. In other words, the blue band is used to draw attention of the end user to whatever user command the fair share application is responding to. Let's check that by looking at the final report version of the same command. We are going to use the fair share application. We had used the fair share application to generate report for one of the roommates. We should now see the report area in a blue band, and there you are. So we have used style sheets in a very different way. What was purely just a piece of information that was given out by HTML has now just by using the styling system, we have used it to focus on what exactly is being responded to. If our application program, FairShare program, is responding to a registration request, then that part is given a blue background. If our program is responding to an expense request, then the expenses block is given a blue background. If our program is responding to a report request, then that is given a blue background. And at every point, the actual database information is also displayed out. If you observe, this database information looks similar to the spreadsheet, the way the spreadsheet looked. But there are some things that are remaining. For example, the vertical lines here that separate the columns of the table and the horizontal lines that separate the rows of the table have not been shown. One of the practice exercises that we suggest you do is to try to write CSS such that these columns and rows, the lines, vertical separators and horizontal separators, are also seen. That would be a good way to really get going on learning CSS and HTML. With that, we come to the end of this session. We have seen just how an HTML plus CSS version will sort of look. In the next session, we will actually take the code and see how it differs from the simple command line application. When we see the differences, we hope that you can see how the command line code was changed incrementally to obtain the HTML version or HTML plus CSS version of the code. The incremental step is simple. It is not difficult, but it is tedious. It is a bit more tedious to write that much amount of code to generate HTML output. It is not difficult, but it is tedious. See you in the next session.